Okay, 11.9, number 4, page 535. Okay, so I'll draw my circuit. Wow. Still can't believe how tricky it is to draw on those. Okay, so this becomes parallel. That is a resistor, sorry. So that's R1, that's R2. Okay. Down here. That's R3. Okay, and then it goes to 2. Again, I apologize for that drawing. It's not very pretty. So this is R3. It's R4. It's R5. We are told. Okay, so they call it exactly how I taught you guys. So V1, V3, and all of those things. Okay, so let's just make a list on the side, and we'll work it out from the side. So V1 equals 2.5 volts. So we're looking for V2. We're looking for V3. No, sorry, we have V3, 5.0. Okay, so we have V1, V2, V3, V4, and V5. We need I1, I2, I3 is 0.15 amps, I4, it's tricky, I4 is 0.1, R4. Oh, we have to figure all of these guys. Well, that's neat. Okay, that's fun. R4. No, let me erase this. So we'll find R1, R2, R3, all in sequence. Which one do we know? R4. This one is this 70. That's a great problem. Oh, that'd be a good one on your test, guys. So we're supposed to find all the rest. Okay, beautiful. Let's have fun. Okay, it'll take a lot of space, this one. Okay, so let me think. So we know V3, so we know this. This is 5. I won't use my sig digs just to simplify my drawing. This is 5 volts. V1. So we know that's V2 as well. That is 2.5 volts. So we know that this is 2.5. So we can fill this up. So we can't know this because we don't know V total. And we're missing VT here. And we're missing IT. Nope, we're missing I5 and IT. We're missing RT. Okay, that is a big one. What else we know? We know I3. Ooh. We know something good here. We know I3 is 0.5. Ooh. So we can find R3 quite easily here. So R equals this over this. So it's 10. So this is 10 ohms. Okay. That's equal. That's not negative. Am I missing something? This is 5 volts, and we know I here is 0.5. So R equals V over I. So this is correct. And this is 10. Okay, so this is correct. So this is 10 ohms. Now that's a big deal here because we know IT. That's 0. Okay. We know this one, 0.1. So there is 0.1 amps going here. So this means, and minus, that means you know there's 0.50. This is 0.10 amps going here. Oh, what am I doing? 4, because you minus. This is 0.40. Sorry. It's 5 volts. Wow, those are neat to think. I1, so I can't know this because I don't know R1. Which one can I do now? No, R3, okay. So this one, it's done. I can't do anything else. So I'll put a check, I guess. So I can't do anything else about this strand. That's I3. So I'm done. I know IT, this is correct. I know I5. I know I4. This is 2.5. This is good. Like, we'll find it. It's just a matter you need to think about it. It's complicated. Where I could find. Let's try. I want to do that. Okay, so this is useless now. So I know R4. So this is 70. Right? So this is 70 ohms. Put it here. 70 ohms. So I can find my drop of volts here. Because I know this is 70 ohms with this. Yeah, that's my next step. If I can find V4, I'll be able to find V4 and V5 because of this guy. Because I know the current, I'll be able to find the resistor. Okay, this is very good. It's moving now. Okay, so 70 ohms. So my volts for this, so V4 is RI. So I multiply them. That's my current. That's my ohms. So R times I, so it's 7. So this is 7 volts. So that means V5 is 7 volts. But because I know that there's 7 volts here, I know my current, I'll be able to find R5. So R5 is V over I. So this is amps. This is 7.0, okay. So it's 7 over 0.4. I need to multiply that. Scientific calculator. What were my numbers? 7 over 0.4. Nope. 7 divided by 0.4. 715. 7.5. What was mine? 17. Okay. Oh, so I know V total now, right? 7 plus 5 plus 2.5. So that's 7.5, so that's 14.5. Okay, oh. It's moving. So I'm just missing R1, R2, and I1 and I2. I get the feeling I won't be able to find the exact values. I'll just be able to find the R equivalent of these two. So now my V, okay, so now this whole circuit looks like this. I'll draw a mini version here. Okay, so I got this thing, and then this thing. Imagine it goes here. What was our volts? 12.5? No, 14.5. So this is 14.5 volts. We know there's a drop of 2.5 volts here. We know there's a drop of 5 volts here. We know there's a drop of 7 volts here. It's 2.5. And we know IT. That's the big thing. Is we know that's 0.5 amps. Now we can find RT from this, right? So RT equals V over I. So it'll be 14.5 over 0.5. So divide by 0.5. So divide by a fraction. So multiply. So it'll be twice. So this is 39. This is 39 ohms total. Man, that's a good problem. This, okay, just picture, it gets really messy quickly. This whole thing here, R4 and R5, they're in parallel. What was this, 70 ohms? Yeah, that looks good. 70 ohms. So R equivalent of this guy, this thing here, R equivalent. So it's equal to 1 over 70 plus 1 over 17.5. Bracket this, exponent -1. That's ugly. 1 over 70. Now, to be honest, so I'll do 70 exponent -1, because 1 over, that's what it is, right? Plus 17.5 exponent bracket. I'm putting bracket for the exponent because otherwise it acts up, like it doesn't keep the -1. I'll put bracket to this. I have to do this exponent -1. I hate doing this. Answer exponent -1 equals, okay, 14. So this thing is 14 ohms. Our equivalent of this here, it's 14 ohms. Okay. Okay, so this is 14 ohms. This is, I had it earlier, R3, this is 10 ohms. Right, do you see what I'm doing here? Is RT is 39, so I go 39 minus 10, that's 29, minus 14, that's 15. So our equivalent of R1 and R2 is 15. That's if I did that right. Let me just do that again. 29, 25, 15. This is correct. So this thing together is 15 ohms. Okay, they're trying to trick us here. So our equivalent of this is 15. They're trying to trick us. I cannot think of a way to find the actual value of R1 and R2. Am I missing something? I don't know. Yeah, the issue is I don't know the current in I1 and I don't know the current in I2. I cannot find a way to figure that out. What I know is that I1 plus I2 give 0.5, but I don't know how they split. R1, R equivalent, R2. I think I'm stuck here. I think I'm stuck. So what you can do, I'll have to go down. So what you can do is create an imaginary R1 and R2 that would work, that would give in parallel 15. Don't do that often. The easy way to do this would be to say 15 equals bracket. Then you put 1, and then you put a random value here, and you put a next here, and then you solve. So you can find any R2 for an R1. So we could do it like that. So let's say the first one is 100 ohms. What's that X so that I get a 15 ohms equivalent? That's the long way. The short way, I'm trying to remember, does it split in half? So if I have two resistors that are, just have to think outside the box here. So if I have two resistors, let's actually, yeah, let's pretend they're 2 ohms. Is R equivalent of this 1 ohm? I don't think that's true. R equivalent 1 over 2 plus 1 over 2. My question is that 1? What is this? That is actually 1. Because this gives 1. Okay, so that does work. So this is 1 ohm. Okay, so all you have to do is pick 2 bars that are equivalent. So it doesn't matter. 2 ohms. No, hold on. What am I doing? They have to be 30 if you make them equivalent, because you want it to be 15 ohms. That's right. So that would have to be 30 ohms, but they could really be an infinite amount of values for this here. You can make it 100, 130, 131, and then this one would adjust so that it's 15 ohms equivalent. And then this here, again, depends on the values of the resistor. So in this case, because they would split even, in this case, 30 ohms, it would be 0.25 each. But I'm assuming amps. I'm assuming that it's 30 and 30. Okay, that was a good one. Let's see what the book has to say for answer for that. That's 535. I'm just curious about I1 and I2. I'm going to guess that they go equivalent, but that they don't tell us that they could be an infinite amount of possibility. I'm going to guess they do that. Let's see if I'm wrong. 4. So V total 14.5, that's good. V2 2.5, that's good. V4 7, that's good. V5 7, that's good. IT is 0.5, that's good. I1 What are they doing there? 0.2? They can't know that. That's what I was saying just now. They can't know that. I really can't think of a way they find 0.2 for that. I5, do I get this right? I5, where are you hiding? I5.4, yes. R1. So they pick, what? How can they? How do they know it's 13? So R1 and R2 there, I strongly disagree. R3, 10, that's good. R5, okay, so they round to 18. I had 17.5. Now R total, 29. 29. Let me redo my steps. So 29 ohms. Did I do a mistake on my calculation here? Let me just go back one step. So that was correct. Where did I calculate this? That was here. And I found my R equivalent for this. That was correct, right? Because they found R4. They have R5 at 18. Right, but they don't tell us this one. Right, so they're not telling me this one. That's okay. Okay, I'm suspicious I did anything wrong. Really doubt I did anything. Let me check again. Okay, I'll pause this. Okay, so I was just looking here. They're really making no sense when they say here they get 29 here for this, but that really, unless let's just check something here. This is correct. We know it's 14.5. We know this is 7. This is correct. It's by the book. It's the same 5 volts. We're given this one. If you add this is 12, 14.5. This is correct. The problem is that they give us I3. They give us this one, this current. We know IT, because this is in series here. We know it's 0.5. We have no option. So the whole circuit, it's equivalent to this. It's equivalent to battery, one resistor, and I is 0.5 amps, and that's 14.5. We have no option. This is correct. That's their IT, that's their volts. If you, oh, did I do a miscalculation? Oh, I did. Oh, I did it mentally. Oh, crap. Oh, I hate this. Oh, should have gone on the calculator. I just realized it is 29. Crap. Okay, it is 29. Oh, I hate this. So it is 29 ohms. So it changes those numbers here. I hate this. So I have to go back. Okay, so that's 29. So there's 10. Okay, so it's a super small value then. So 29, 19. So there's 5 ohms left. So it's not 15 ohms here. This is 5 ohms. This is 5 ohms. Five ohms. So what does that tell me? What does that tell me? Where did I go next? So this is 5 ohms. Okay, so then if I make them, right, so if I go back to my rational here that I had earlier, So I could make both be 10 ohms if I wanted them to be the same value, because this has to be 5 ohms, but then my I, in this case, would split to be the same. So let's just confirm how that changes things. For it's R1. So they okay, so they're picking two random values, 13 ohms and 8.3 ohms. It's totally random. Does this work to give? Let me just go here. Try to see if that gives 5 ohms. R equivalent, getting messy, eh? If I have 13 bracket plus 1 over 8, 8.3. This has to give 5 if they get it correct. It looks like it will, because the numbers, they fit. Let's try that. Let's go on the calculator. Okay, what was it? 1 over 13. Okay, so bracket, 1 over 18, bracket, plus 1 over 8.3, bracket. Is that it? Oh, it's 13. This thing. 13, bracket, plus 1 divided 8.3. Bracket, exponent, bracket, -1, bracket. Okay, perfect. So their numbers work. Yeah, so they just picked random values, but you could just pick 10. That's much easier, much lazier, and you would get equal values for current. Single mistake when I did it mentally here, trying to find my RT. Subtract. I multiplied something. Okay, so there it is.